Assalamu alaikum dear students. We are discussing exercise 1.1, and in previous lecture we discussed question number 1. Today we are going to discuss question number 2. Now here we have to prove that a relation or defined on a set of real numbers as the relation is defined as order or is set of all those ordered pairs, that is a b, where a is real, b is real. This means that or is relation on or by a less or equals to b square. Now this OR contains only those ordered pairs whose first entry, that is a, is always less or equals to b square. We have to prove that this is neither reflexive nor symmetric nor transitive. Now for reflexive relation, in order to disprove the result, that is we have to disprove this reflexivity, we need just one example, while as on proving we have to prove in the general. Now if a equals to 1 by 2, because a equals to 1 by 2 is a real number, so it belongs to R. Then 1 by 2 is always greater than 1 by 2 square, because 1 by 2 is 1 by 2 1 by 2 cos square is actually 1 by 4, and 1 by 2 is greater than 1 by 4. So this means that 1 by 2 means is not less or equals to 1 by 4 or 1 by 2 square. So this means that if a equals to 1 by 2 belongs to R, here a is not less or equals to a square. So a does not belongs to R in general or for all, but in some cases we have, like if we consider a equals to 2, because 2 is real, then 2 is always less or equals to 2 square. This is true, but for the rationals of the form of p by q, which are not integers, it is not always possible. So this means that this relation is not a reflexive relation, because there exists an element, or there exists an element at least one, which is 1 by 2, where a does not belongs to R. So this means that this relation is not a reflexive relation. Now for symmetric we have to prove that if element belongs to this R, that is AB belongs to R, should imply that BA belongs to R. Here 1 4 belongs to R. Why 1 4 belongs to R? Because 1 is always less or equals to 4 square. 4 square is 16, which is true result. So this means that 1 4 belongs to R. But 4 1 does not belongs to R. If 4 1 belongs to R, should then 4 is always, then according to this 4 should be less or equals to 1 square, which is absurd. Hence 1 4 does not 4 1 does not belongs to R. That is 1 4 belongs to R does not imply as that 1 4 1 belongs to R. Hence this relation is also not symmetric relation. For transitive relation we need two elements of the form of AB and BC. One is here 3 2, because 3 2 belongs to R. 3 is less or equals to 2 square, because 3 is less than 4, and 2 1.5, that is 1 by 2 actually, sorry, 3 by 2. Here 2 is always less or equals to 1.5 square. 1.5 square is 2.5, that is why 2 is less than or less or equals to 2.25. So we have elements of the form of AB and BC. Now if it is transitive, then these elements should imply that AC means 3 and 1.5 should belongs to R. Now if 3 and 1.5 belongs to R, then 3 should be less than 1.5 square, which implies that 3 should be less than 2.25, which is absurd. So 3 is not less or equals to 1.5 square. So 3 1.5 does not belongs to R. Hence this R is also not transitive, because we have elements of the form of AB and BC, but they do not imply as in general that BAC belongs to R. One element is 3 2, second one is 2 and 1.5. You have number of, you can prove this, or you can disprove this through number of elements. Now the second one, question number third of this is we have to check relation which is defined on set A equals to 1 2 3 4 5 6 by R equals to AB, means those ordered pairs AB, while B equals to A plus 1, and A, B belongs to this A, that is A and B are 1, 2, 3, 4, 5, 6. We have to check its reflexivity, symmetric and transitivity. Here R is defined as AB, where B equals to A plus 1. This means that R equals to, now when A is 1, B equals to 1 plus 1, that is 2, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. Now if we put A equals to 6, then B comes out to be 7, but 7 does not belong to this A, so we have to stop here, or we can simply say that it contains only these 5 elements, this R. Now we have to check its reflexivity. Now here 1 belongs to R, or 2 belongs to this A, 3, 4, 5, 6 belongs to this A. But 1, 1 or 2, 2, 3, 3, 4, 4, 5, 5, 6, 6 does not belongs to R. So this means that 1 belongs to A does not imply that 1, 1 belongs to R. So R is not reflexive. Also 1, 2 belongs to R. 1, 2 belongs to R. But 2, 1 does not belongs to R, because here we have element 1, 2, but 2, 1 does not belongs to this R, so R is also not symmetric. Similarly, 1, 2, here we have elements 1, 2 and 2, 3, or 2, 3, 3, 4. So we have elements of the form of A, B and B, C, but 1, 2 belongs to R, 2, 3 belongs to R does not imply as that 1, 3 belongs to R. So R is also not transitive relation. So in this way, it is neither reflexive nor transitive nor symmetric. Now the fourth one is we have to prove that the relation defined in the set of rational real numbers as those ordered pairs A, B such that A is less or equals to B. A is less or equals to B is reflexive, it is transitive but not symmetric. Now for reflexive, if A is real number, then A equals to A, because every number is equals to itself, or A is less or equals to A, because less or equal to means either less or equal to. Here we have equal to, so we can say that A is less or equals to A is true, which implies that A belongs to R for all A belongs to real. Hence R is reflexive. Similarly for symmetric, here we put or we take any element from this given relation, that is AB belongs to R, which implies that A is less or equals to B, because by the definition of this R. Now if real number is, there is important law, there is an axiom in the set of real numbers as this, which is called the law of trichotomy, which states that if we have only two real numbers, then either they are equal or less, one number is less than other, or second number is greater than other. So this is there are only three possibilities. Now whenever a real number is less than or equals to B, it does not imply in general that second real number, that is B, is also less or equals to A. So this means that AB belongs to R does not imply as in general that BA belongs to R, because if we consider 1, 2 which belongs to R, but 2, 1 does not belongs to R, because 2 is not less or equals to 1. So this means that this is 2 less or equals to 1 is absurd. Hence in general this R is not symmetric. Now for transit, if we have elements of the form of AB which belongs to R and BC which belongs to R, then if AB belongs to R implies that A is less or equals to B and B is less or equals to C. Now we combine these two statements as A less or equals to B less or equals to C, which implies that A is less or equals to C, hence AC belongs to R. So AB belongs to R, BC belongs to R implies that AC belongs to R. Hence by the definition of transitive relation, we can say that this R on the set of real numbers is transitive also. Hence this is reflexive, this relation is transitive but not symmetric. So thank you.